Hi! In this video, we will study random variables and learn how to find probabilities of specific numerical outcomes. As we all know, most of our observations are in the form of numerical data that are the observed values of what is called random variables. Random variables are used to quantify outcomes of a random occurrence and therefore can take on many values. The number of cars in a parking lot, the average daily rainfall in inches, and the weight in kilograms of an average human person are all examples of quantitative variables. If we let x represent a quantitative variable that can be measured or observed, then we will be interested in finding the numerical value of this quantitative variable. We will now use a random variable that maps the elements of the sample space to a set of numbers. If we flip 5 coins and want to answer questions like, what is the probability of getting exactly 3 heads? What is the probability of getting less than 4 heads? What is the probability of getting more than 1 head? Then we should represent our question using a random variable and write it as the probability that x is equal to 3, the probability that x is less than 4, or the probability that x is greater than 1. Random variables are also seen in real-life application. Let us look at it through this example. Suppose we have a random process or experiment of votation. 3 voters are asked whether they are in favor of implementing face-to-face classes in their certain school. Each voter's response is recorded as yes or no. What are the random variables that could be of interest in this experiment? As you may notice, the simple events in this survey are not numerical in nature since each outcome is either a yes or a no. However, one random variable of interest is the number of voters who are in favor of face-to-face classes. In the first simple event, all 3 voters responded yes. Meanwhile, there are only 2 who agreed on the second event and 1 to the third. To denote a random variable of interest, we use x to represent the yes vote that we gathered on the random process. Therefore, we can write x is equal to 3 to the first simple event as there are 3 yes votes, x is equal to 2 to the second, and x is equal to 1 to the third simple event. Here, the random variable x is mapping the outcomes of the random process and leading us to its numerical values. The use of random variables makes our task easier to quantify results of any random process and apply math and perform further computation.